All right, today we are looking at the beginning of chapter 4, and we are going to be studying ratios in right triangles. In chapter 3, we looked for relationships between triangles to determine if they were similar or congruent, but now we're going to focus our attention on slope triangles, which you did use in algebra to describe linear change, but we're going to be looking for geometric patterns within them. Okay, so in order to find an angle, you need to investigate the relationship between the angles and sides. So we're going to start by looking at this slope triangle in particular here. Now it asks me to draw 3 new slope triangles. So I am going to take a minute and draw one. So here's the first slope triangle. I just made it bigger. I made the rise 2 and the run 10. And the next slope triangle, I made the rise 3 and then the run was 15. And the final slope triangle I drew here had a height of 4 and a run of 20. It also wants me to include angle measures here, so I know these angles here are 90 degrees because it's a vertical component and a horizontal component. Then there's some important questions to consider. The first question is, are these triangles similar? Meaning, are the 4 slope triangles that I've drawn similar? The first one's 1 and 5, and the second one was 2 and 10, and the third one was 3 and 15. And keep in mind, I also know all of these angles in here are 11 degrees because they're on that same line. So I would know all of these triangles are similar either by angle, because they all have a slope angle of 11 degrees and they all have a 90-degree angle. So it'd either be similar by angle, or by side angle, side. And that's really important because when I know triangles are similar, I know that their ratios are equal. So if I'm checking for these triangles to have equal ratios, I would check the slope of the first triangle, the slope of the second triangle, the slope of the third triangle. All of these would have a slope ratio of 0.2. Sorry, I noticed that should be 3 over 15. All of these have a slope ratio of 1/5 or 0.2. That's important to know because if these triangles are similar, every time I see an 11-degree angle, I know that it's going to have that ratio. So I'm going to do investigations here. I'm going to keep track of my information. 11 degrees always has a ratio of 1/5. It doesn't matter how big the triangle is, because it's always going to be similar to this original triangle here. So I know that this ratio of the change in y over the change in x is always going to be 1/5 when the angle is approximately 11 degrees. So we're now going to use this idea for additional triangles. So I'm going to keep my 11 degrees and my 1/5 ratio handy. Tara thinks she sees a pattern in the slope triangles, so she asks a few questions here to investigate whether the pattern remains true. What if I draw a slope triangle on this line with delta y equals 6? Well, my line was like this. So if I keep that angle at 11 degrees, and this angle here is 90, if the change in y is 6, what's the change in x? Well, in order to solve that, I'm going to compare that to the original triangle here of 1/5 because I know the triangles are similar, so their sides have to be proportional. So I'm going to say 1/5, the ratio of the rise over the run, has to equal the ratio of 6 over x. And then I'm going to use my cross products property, and I'm going to multiply and get x equals 30. Okay, what if delta x is 40? So same line, again, this is the 11-degree line. If this is 40, what's the change in y? I want you to pause the video, solve it, put your answer in. Again, I'm going to compare this to the 1/5. So 1 over 5 equals y over 40, and I'm going to cross multiply using my cross products property, and I'm going to get y equals 8. Okay. Tara wonders, what if I draw a slope triangle on a different line? Can I still use this same ratio to find a missing change in x or change in y value? The answer is only if the new line has an 11-degree angle. Okay, if I'm comparing any line that has an 11-degree angle, I know that its rise over run, its slope ratio is going to be approximately 1/5. If I'm looking at a line that's 35 degrees, I don't know what that ratio is because it's a different angle. The triangles are not going to be similar. So I would have to find that different ratio. So we're going to dig into this idea just a little bit more and investigate just a few more angles. Okay, so then what if we look at a different line? We're going to look at what happens when we graph the line y equals 2/5 x. You can go ahead and hit pause and graph on your handout. I'm going to graph here. So I've gone ahead and I've graphed this line, y equals 2/5 x. If I were to draw my slope triangle, I would see that my ratio is 2/5. I'm going to take my protractor and I'm going to measure this angle here. I'm going to expect that it's going to be something different. When I line up my protractor on it and measure it, I find that that angle for a triangle with a slope ratio of 2/5 is about 22 degrees. So my 11-degree angle had a ratio of 1/5. My 22-degree angle has a ratio of 2/5. I investigate a couple more ratios here. This one says, what if I have an angle that's 18 degrees? So I'm going to pause. I'm going to take my protractor and I'm going to draw an 18-degree angle here. And then we'll come back and look at the slope. All right, so this angle drawn here is 18 degrees right here. That angle is 18 degrees. And then I'm going to calculate my slope triangle here. I'm going to count. It looks like my rise is 3 and my run is 9. So my slope triangle for ratio for an 18-degree angle is approximately 1/3. Okay, so the whole point of this is to realize that different angles have different ratios, and that makes sense in terms of what I know regarding the steepness of a line. All right, one more here. We're going to graph this line y equals x plus 4. So my graph is going to start up here at 4, and I'm going to go up 1/1, and I'm going to investigate this triangle here. Now this slope ratio is 1, and I know this triangle is isosceles. So if these are 1, that means I have 180 minus 90. I have 90 degrees left to be split up. These have to both be 45 degrees. So I know a 45-degree angle has a ratio of 1. If you take a look at the math notes from lesson 4.1.2, it summarizes these ratios nicely. Okay, we are going to use this table for today, and then eventually we'll get a better tool that we're going to use. But right now, I've discovered that these different angles have these different ratios. So anytime I see a triangle that has an 11-degree angle, I know that the ratio of rise over run is going to be 1/5. Anytime I have a triangle that has a 22-degree angle as its slope angle, I know that the ratio is going to be 2/5. 18 degrees is 1/3, and 45 degrees has a ratio of 1, because if I compare that 3/3, I know that that equals 1. That makes sense to me because I know that triangle is isosceles. So keep this table handy. This will be helpful for you as we solve some equations in class. Okay, I'm going to give you this problem and I'm going to see if you can solve it. I want you to go ahead and enter your answer. The question is, use the slope ratios to answer the question below. This is an 11-degree angle, so I know which triangle it would be similar to. Use what information you know to find your answer for x, and then go ahead and answer that question. We will pick up and apply more of this tomorrow. Thanks for watching.